Hey guys, welcome back to Kill It Simple. So today we are going to be discussing how to create a flowchart for linear search and linear search and binary search, both of them. All right. So let's begin. So first we are going to be designing for linear search. That is going to be your user defined. Let me mention over here user defined flowchart. That's it. These are your user defined flowchart, and how you're going to be implementing is quite good. This is Yeah, user defined. All right. All right. So let's begin with first linear search. So how you are going to do is you're going to create this two side half circle box and just going to write linear underscore search with its parameter consisting of first an array itself, second its size, and third its key. All right. I'll just also mention in side to side that what's going on. So this is a user defined function for linear search consisting of parameters that are ARR, size, and target. All right. Now let's move to the next step. That's quite easy. We are going to be implementing a looping statement that is your for loop to implement linear search. This is how it is designed. It's a typical hexagon uh, with two lengthy sides. What you're gonna do is you're just gonna write for. Now the range I starts zero from 0 to n minus 1. That is to the last index element. Looping statement. Looping statement where I is 0 and I is less than n, where I will keep on incremented until we reach. Alright, now next is we have to search. In order to search, the best implementation is an if else condition box. Um, Sorry for my bad drawing. It's like, I know, a bit horrible, but since I have only this kind of way of representing my work, so this is the best possible way for me right now. So just write is ARR I equal key. If it is present, then there are two possible conditions that would work. First, create a false. Just create a line and write the false, because this false statement comes at very last. That means this false statement will come when the this for loop is closed. Now, in order to, I might have made really hard scroll. Let me come up a bit. Now, there is a true condition, right? True over here. Writing true false is a necessity. Now, what could be the true condition is return return true, and the false is return false. This is what we have been expecting. Now, how to end this? Ending is quite easy. You have to just simply return. Oh, wait. The main step is close this for loop. This is how you close. You have to create a small circle and then create a dotted line from the end of this box. Just like this. Bring it down to that particular box. Circle I meant, not a box. And then there you see your for loop is closed. Now the false statement will end after that loop is closed, like this. That's it. And the final statement or the box will be to return linear search. How you will write is return. No, you have to just write return. So let's shorten the box. That's it. Just write return. That's it. This is how you implement linear search flowchart for user defined functionality. That's it. That's it. Now let's go for uh, binary search. This is how you implement same procedure. First step. Let me also write in the above so that it can benefit you. Over here, the third statement was check conditional conditional box with true false parameter and return linear search. Linear search with true value. That's it. Now you understand. Now we'll be implementing for binary search. Yes, you heard me right. That's binary search with a time complexity of order log n, which is considered the most efficient uh, search till in today's date. What you're gonna do is you're just gonna draw with me. Let me search that thing again. Yeah, there it is. My writing pen. Gonna extend it. You're just gonna write binary underscore search with parameters consisting of array itself, a size, and a key. Let me shorten it up. Let's quickly design it. I mean, because otherwise the video will be too lengthy. And now let me tell you one more thing. Uh, that yeah. So let's design. Yeah. How you will begin is quite easy. Yeah. Next. Next is yeah. How you're gonna start is with this rectangle box. And why? Because in binary search we often play with two sides, that is left and right. All right. How you're gonna implement is quite easy. Maybe the box might be a big for that purpose, but let's write. The first parameter is declare left, that is assigned to 0. Declare right, that is assigned to n minus 1. Let me write over here comma. Now there are two parameters in this binary search, that is left and right. Left denotes the starting index and right denotes the ending index of that particular array. Now next is a while condition box. Now a while condition box is quite interesting, I would say. This is how it works. Just simply have to create an if else box, that is a diamond box. Similarly to that is a while box. While box often has first false statement, false at the beginning. That is, you can write anything inside it. Let me write. Um, let's write return false. Return false. And return. That's it. That's it. You just return the final value. Alright. Otherwise, what it is gonna do is it's gonna keep working. How? Is left less than equals to right. If it is true, then only we will move forward. Ending with a question mark. Now, the first condition should be every time based on the mid value. In order to find the mid value, we have to provide a formula for calculating that, which will come under a rectangle box itself. How do you calculate mid? Declare a mid, declare mid, assign to left side first, then minus, sorry, plus, then again left minus right, divided by 2. Left plus left minus right divided by 2. That's it. That is how you calculate mid. Now we will be cross checking it in the if condition only. How you're going to implement is quite easy. Again, there will be a diamond box. That's it. You have a diamond box over here. This diamond box is based for three conditions. Yes, it's based for three conditions. Now, this diamond box is checked for first condition, that is ARR mid. That is how that we calculate the middle element is equals to key, that is k. If it is, then for true condition, yeah, return return true. That's it. Else if. Now for false, what we're gonna do is create an else if conditional loop. And how we create it is by doing this again. Yes, I know it's a bit lengthy to design a flowchart, but when you understand the flow, you are able to design it with a ease. Now for else if statement, what can be the possibility? Maybe that element might be present in the no, maybe that present element on the middle may be less than. So what you're gonna do is ARR mid less than K? If it is, then or maybe let's check for less than K first. If it is, then true, true. Alright. Now if it is true, then move this, move this, and in that formula, oh sorry, now design a rectangular box and just write left equals to mid plus 1. When you do that, just connect it with this true statement. That's it. Now let's move to other. Let me just scroll it. When you have checked for true condition, now for false condition. Now remains is that maybe the ARR mid is greater than K. Now for that, we're not gonna create another conditional loop box. We're just gonna check for from the high side, from the right, not high, right. That is going to be mid minus 1. Why we are writing mid plus 1 and mid minus 1 is when if it is in the left position, then it will keep incrementing every index from that left position, and if it is false, then it will be uh, decrementing from the right position. That's it. If it is fine in false position, then it will be it will also return true, so connected with this line, and eventually this line is already connecting with a true fundamental property. Now we are done. All right, let me shorten it a bit more. All right, now just connect this return true with this while ending over here, and just write over here true. True, false, true, false, true, false. That's what we are playing with. Now, if it is return true, then it will automatically return true, otherwise, it will return false. That's it. That's how you design a flowchart for binary search. This is for linear search. Let me write linear search. And this is for binary search. Binary search. That's it. That's how you create. Now, the difference and other properties, I might recommend you to go with your textbooks. Maybe ChatGPT might be the best version to explain it more in a friendly manner. The main difference is that linear search uses an order n complexity, and binary, on the other hand, uses order log n. That's it. We have one more search, that is jump search. I'll create a flowchart video for it in the upcoming video sessions. Till then, we are going to be designing the main program. That's a bit uh, asked. hmm, in the comment section, most people ask me to design the main program as well. So I'm going to be designing the main program. Let's just design the main program quickly. How you design a main program is bit easy compared to the user defined function, because you have to just call the main function. This main program is for both, so don't get confused. It's same for both. What you're gonna do is just simply write this, that is going to be start. Second, you have to declare. Why you have to declare? Because you're going to be taking some input variables, that is declare. First, you're going to be taking and just remove this comma, declare. You're going to be taking first ARR, that's array. Second, you're going to be taking size, let's name it n. Maybe size might uh, work more better. And third is target. All right, that's how you write it. Now, first input size. How do you do is by this side box, rhombus or parallelogram, that's what you're gonna say. Read size. You have read the size. Now you have to input an array. How you're gonna do is you're gonna be implementing a hexagon. that is a loop box. Just create it. For I from. Yeah, declare I as well. Yeah, we need to declare I as well because most professor demands for declare I. So we are gonna just declare I over here and over here. How you can declare over here is, let me just make a pathway for it. And it's not necessary to write for I, but in some universities I have seen it's really compulsory to make even one more most impression. So this is how you have made. Let wait just 1 second, guys. Let's name it like this. That's it. That's how you go over there. That's it. Now let's make it in that manner. Just create a rectangle box and just write declare I. Declare I. That's it. That's your work. Now it's done. Alright, we have declared already in the binary search, so that's not a concern anymore. But if you know, then you know. Now let's come back to our main program. Alright, let's finish up with the main program quickly. From for I from 0 to size minus 1, that is n minus 1, from 0 to size minus 1. That's it. Now read your array, read ARR. That's it. Close the loop. That's how you close the loop. That's it. Now, just to move a bit. Just sorry, guys. That's it. Now, when you're done with this, read your target. Read target. That's it. Read your target. Move next. Now, create a conditional box. The line was much more efficient. Now, is you have to call your linear underscore search or binary underscore search. Alright, I have already mentioned or. That means you can use any one of them. The parameters will be same ARR and comma K question mark close the loop. Just write exactly and then but yeah, I have taken full name so you have to mention the full names. Not NK size and target. I don't have enough space right now. Let's leave it. But you guys remember, you don't have to write NK. Let me write over here. That is size and target. Write full name. You don't use shortcuts like me. Now next is an else condition. Sorry. False and true. Let's move a bit down. What just happened? Now, true. What you're gonna do is you're gonna print the final output. Just for this and for this. In false, just print invalid. Alright. And in this, print key found or target found, whatever you need to write, and just write stop. That's it. This is your main program. Let me shorten it up. So as you can see, this is how you create flowchart for linear search and binary search and main program. This is the full representation. So I hope you liked my video. So support me, subscribe me, and like, share as much as possible. Thank you for watching.